and welcome to What's Up With That, the series that demystifies all things Chrome. I'm your host, Sharon, and today we're talking about content. What lives in the content directory? What is the content layer? How does it fit into Chrome and the web at large? Here to answer all that and more is today's special guest, John. He's not only a content owner, but actually split the codebase to create the content layer. Since then, a theme of his work has been Chrome's architecture and how to make it usable by others. He's been involved far and wide across Chrome, but today we're focusing on content. John, welcome to the program.
Hi everyone, and thanks for setting this up, Sharon. My name is John, and I'm happy to try to shed some light and history on this part of the Chrome codebase. I've had the pleasure of working on a lot of different parts of Chrome over the number of years I've worked on it. A theme of my work has been on the architecture of Chrome and making it reusable by other products. And one of the projects has been splitting up the codebase and helping create this content layer.
Yeah, so can you tell us what the content layer is? Because content is a very overloaded term, and we're going to say it a lot today. So you mentioned the content layer. Can you tell us what that is?
Yeah, the content layer is a part of the Chrome codebase that's responsible for the multi-process sandbox implementation of the web platform.
All right. And another term that I had heard a lot tossed around before I really understood what was going on was the content public API. So is that the same as the content layer, or is that different?
It's part of it. So the content component is very large. And so we've surrounded it by this small public API so that kind of you hide the implementation details in the private directories, and then embedders just only have access to a small public layer.
Okay. How did we end up with this content layer? Can you give us a bit of history of how we came up with it, and also maybe why it's called content?
Sure. The history is, like in the beginning, Chrome, like all software projects, begins nice and easy to understand. But over time, as you add a lot more features to go from 0 users to billions of users, it becomes harder to understand, right? Small files, small classes become much larger. Small functions kind of get numerous hooks to talk to every feature because they want to know when something happens. And so this idea started that, okay, let's separate the product, things that make Google Chrome what it is, from the platform, which is what any browser, any minimal browser, kind of doing the latest HTML specs would need to implement them in a sandbox and multi-process way. And so content was the lower part, and that's how it started.
How did we get the name content?
The name is kind of like a pun. When we started Chrome, one of the ideas was, we'll focus on content and not Chrome, and so the browser will get out of the way. Chrome is a term used to refer to like all the user interface parts of the browser, and so we said, it's going to be content and not Chrome. And so when you open Chrome, you just see a very small UI. But most of what you see is the content. And so when we split the directory, it was originally called Source Chrome. And so the content part, that's kind of the pun. That's where it came from.
Okay, that's fun. Earlier you mentioned embedders of content. Can you tell us what an embedder of content is? And this is part of why I was very excited about this episode, because I was working on a team where we were embedders of content for a long time, well over a year. And it took me a long time to really understand what that was, because as you mentioned now, Chrome's grown a lot. You work on a very specific thing. Understanding these more general concepts of what is content, what is a content embedder, are less important to what you do day to day. But can you tell us what an embedder of content is?
Sure. An embedder of content is simply anybody who chooses to use that code to build a browser on top of it. And so, in the beginning, right when we did this, the goal was just to have one embedder, or not the goal, what we had was just one embedder, it was Chrome. But then right away we were like, you know what? It would be nice for people who work on content and not like the feature part to build a smaller binary, builds faster, debugs faster, runs faster. And so we built this minimal example also to other people called Content Shell. And then we started kind of running tests against that. And that was the first or the second embedder of content. And then since then, what was unexpected, what we started for code health reasons, turned out to be very useful for other projects to restart or start building their browser from. And so things like Android WebView, right, which was kind of using its own fork of WebKit, then started using content. That was kind of one kind of first party example. But then other projects came along, things like Electron and Content Embedded Framework, all started building not just products on top of it, but other frameworks.
Yeah, that was really surprising to learn about because it seems unsurprising that you would build another browser based on Chromium, and people have heard about this, right, when Edge switched over to Chromium, but to learn that things like Electron are built around content seem really surprising because that's very different from what a browser is.
Yeah, I mean, but they have kind of common needs, right? They have some HTML data, and they want to render it and kind of do so in a safe and stable and secure way, and kind of that's not their value add, right? Kind of working on that code, so it's better for them to reuse something else.
That makes sense. You also mentioned that Chrome is dependent on content. And when I first started working on Chrome as an intern, I had it told to me so many times because I couldn't remember that Chrome can depend on content but not the other way around. So can you tell us a bit about this layering and why it's there?
Yeah, I should also start by saying, content is not just, like when we say content, often what we mean, like you embed content, you embed content in everything that sits below it in the layer tree. So that includes things like Blink, our rendering engine, V8, our JavaScript engine, Net, our networking library, and so on. There's also, you can kind of talk to the content public APIs, but also sometimes you talk to like the Blink API and the Net, the files and V8 and so on. And
so you have this many-layered API or product, really, and at the bottom we have things like Net, Blink, and those probably have dependencies on them that I don't know about, and on top of that we have content, and then on top of that we have Chrome.
Right, and so Chrome as an embedder of content can include directly the content public API, but since content can have multiple embedders, it can't include Chrome. If content reached out directly to Chrome, then other people wouldn't be able to use it, because if you try to bring in this code, it includes files from a directory that you're not using. So instead, the content public API, it has kind of APIs going two different directions. One direction is going into content, and then one direction are kind of these abstract interfaces that go up from content, and any embedder has to implement them. And so these are kind of like, usually they'll end up in terms like client or delegate. And these are implemented by Chrome. And that's how, content is able to call back to it. But then any other, of course, product or embedder can also implement these same interfaces.
Right. You mentioned Blink and also some things called delegate and whatever. So we have a lot of things called something host in content. Can you talk a bit about what the relationship between content and Blink is? Because there's a lot of mirroring in terms of how they might be set up and how they relate to each other.
Yeah, so Blink was the rendering engine that originally started as WebKit, and we forked and renamed it Blink a number of years ago. And that did not have any concept of processes. So it was something that, you call it in one process and it does its job, and you give it whatever data it needs, and it, gives you back, the rendered data, and you can poke at it or whatever you want to do with it. But you needed to wrap that with you need a bunch of code around it to make it multi-process, and also to figure out when it needs something that's not available in the sandbox that it runs in, you have to provide that data. And so this is where the content layer comes in. It's the one that wraps the rendering engine and uses, like the networking library and other things to be able to create like a fully working browser.
More about processes. So it's easy to think maybe that the relationship between the content layer and the browser process. So can you just talk a bit about how processes work in content and what the content API provides in terms of accessing these processes?
Okay, so the content code runs in it's the initial process that runs, right? Content starts up, and so it's in the browser process, but it also creates like the render processes for where Blink runs. It creates a GPU process that talks to the GPU and where a bunch of like compositing happens. It creates a network process where we do networking. Creates other processes, things like audio on some platforms, storage process to isolate kind of storage, and then a lot of short-lived processes kind of for security and stability reasons. And so you can have processes that run content code, but sometimes the embedder wants to run its own code in a different process. So it could reuse the same helpers that content has for creating a process, and it will use that. And then I think I didn't fully answer your previous question yet, which was the host part. So kind of often you'll have classes in Blink that are running in the render process, and you need kind of an equivalent kind of class to drive it from the browser process, and that's where we often have the host suffix. So it'd be like a class for.
Can you give an example of a?
Yeah. So for example, like every render process has a class in content browser called render process host, and then every tab object in Blink it will have this class called render view, and then in content browser it will have this class called render view host.
Those are classes that depending on what you work on you might see pop up quite a bit, and there's a lot of them. They're all called render something host, and it's a bit tough to keep them straight, but that makes sense as to why they're called render and why render and host are in the names for them.
Mm-hmm.
So you just listed a bunch of different process types, right? The GPU process, browser process, render processes. And usually whenever we have different processes, we have some sort of security boundary between them. Can you talk a bit about how security and the content layer overlap? Like, is the content API a security boundary? What happens if someone calls it maliciously? What could go wrong if they do and do it successfully?
So the security boundaries, in any browser built on top of content is the processes, right? We separate things, not just have render processes, per tab, but there are multiple render processes per tab, thanks to the amazing work of the site isolation project. And that's kind of what split up different iframes into different processes. And so kind of, how they talk, all these processes talk through IPC, and our current IPC system is called Mojo. And so kind of anytime you talk, use Mojo between processes, you're usually talking from between processes of different privileges. And so one could be sandboxed and the other one not sandboxed, or one could be sandboxed and the other one only partially sandboxed. So you have to scrutinize any time you use these Mojo calls to make sure that they can't inadvertently lead to a security vulnerability. Now, even though it's as hard as you can, people could still misuse code, right? Or also, embedders like Chrome or other content embedders can add their own IPCs. So, content obviously doesn't know about the IPCs from other layers, and so it's possible that it could be an embedder of content that has security vulnerability in their own Mojo calls, and so that's kind of. Content doesn't know about them, so it can't do anything about them. You could obviously, just like you could write insecure code in content, you could also write insecure code in an embedder, right? And if someone finds a vulnerability, so let's say someone finds a vulnerability in Blink, right? And maybe they're only writing their code in a minimal content shell. Maybe they can't find any other Mojo calls that they can kind of abuse to be able to get access to the browser process. But maybe someone else, an embedder, is a more full-featured browser. Has more IPC surface, and that could be more of an attack surface for that, to start with that Blink vulnerability and then to hop into the browser process.
Yeah, and if you gain control of the browser process, that's a very highly privileged process. Right?
Yeah, because that had full access to your system. So that's the point where you can kind of leave persistent changes to the user's system, which is pretty bad.
That sounds not great. So if you're an average say Chrome engineer, and that could be anyone, this is probably not too much of a concern, right? All the stuff we kind of mentioned, this is good to know. How are how would a Chrome engineer who doesn't directly work on content or in the content directory interact with the content layer?
Probably, well, they might need a signal from Blink, for example. That's kind of often how someone will do that. They'll be working on a feature in the browser and everything works great, but then they'll be like, oh, I just need something from Blink, but it's not there, right? And so sometimes they'll kind of have to add an IPC uh, and between processes, and that might kind of interact. They'll be like, okay, oh, how do I get it? Oh, it's in Blink, it's in the render view class. Okay, so I need an interface that kind of talks between like each render view host and each render view, and that's kind of how they might get that would be how they get kind of interaction with the multi-process part of it. But if someone is just working on something only in a browser process, they might still be kind of trying to get information about the current tab, right? And that's represented by a web contents class and content. So they'll look in content public browser and they'll see web contents, and there'll be a lot of interfaces that kind of hang off it. So they'll be looking at it, kind of going through a trail of interfaces and classes to be able to get more information on what's going on in the current tab.
Okay. Can you give us a quick overview of the web contents class? Because it is, one, massive, and two, called something like web contents, which suggests it's important because content plus the web. And it's also something you see all over the place. So can you just give us a quick overview of what that class does, what it's for, what it represents?
Yeah, so, well, I mean, things now are a lot more complicated than before, but if you kind of go back in a time machine and see how these things started, you can roughly think in initial Chrome, every tab, right, had a class to represent the content in that tab, and that was called web contents. And then it was called web contents because we had other kinds of classes. We used to be able to put like native stuff in a tab, and so that would be like called tab contents. But that's kind of gone now, and we just have web contents. So that's where the name comes from. And then for example, there was like render process host, which I mentioned earlier, right? So you kind of have, and then each tab, each web contents roughly translated into one render process. And so now it's a bit more complicated. There are examples where you can have a web contents inside a web contents, and that's more esoteric that most people don't have to deal with. And then, so that's kind of what web contents is for. It'll do things like, it'll take input, it'll feed it to the page, and kind of, every time there's like a permission prompt, you usually go through that. If the page wants access to microphone or video and so on. It keeps track if there's navigation going on, what's the current URL, what's the pending URL. It uses other class to drive all that stuff kind of as you send out the network request and get it back, and that's not inside web contents itself, but it's kind of driven by it and other helper classes.
I tend to think of content as being the home of navigation, which I think is a decent way to think about it, and also is, maybe biased because of the stuff I've been working on. But you have Chrome and navigation and content and all this stuff here. And then separately, you have the actual web, right? The internet, and that has things like actual websites, and there are web standards, and there's things like HTML. And these two things somehow have to intersect, right? But being on the Chrome side, working on Chrome, apart from writing some browser tests maybe, you never really interact with any of the more web things, right? Like JavaScript you don't really touch, that's more Blink, and HTML only in a test kind of thing. So how do these web standards, right, there's navigation kind of web standards and all that, how do we actually make sure that they're implemented in Chrome, and where does that happen?
Yeah, so that happens kind of all over the code, but there's a few critical directories, right? If you look at like net, right, at a low level, a lot of like IETF and some web specs kind of will be implemented there at that layer, either in net or in the network service, which is the code that runs inside the network process. Then you've got V8, of course, our JavaScript engine, and that has to follow the ECMAScript kind of standards. Um, and then there's a lot of the platform standards. Either some of them are only like don't need multiple processes to implement them, so they'll just be completely inside Blink. But some of them require multiple processes, things that need access to devices and so on. And so that implementation will be split kind of across Blink and Content Browser, and so that's kind of, but then how do you ensure that not only you implement this correctly, but also that you don't regress it? So there's kind of a whole slew of tests, right? There's like the Blink tests, which used to be called the layout tests, and those run across kind of like with simple test cases for many features to make sure that each one works. And there's also this kind of cool thing where we share now a lot of these tests with other embedders, and that way kind of you run the same test in every browser. And so when you write a test, you don't have to write it like n times. You can just write it once. So that's kind of how we ensure that we meet the specs.
That makes sense. Yeah, because I've been pointed when I was looking into a class, like what does this do? I've been linked to say one of the HTML specs or web specs, but the whole time I'm just thinking, how do we make sure, or who's checking that we're actually implementing this and correctly, right? But these tests seem like a good way to do it and also ensures some level of consistency across browsers, assuming whether or not the browser you use chooses to run these tests or not, I guess.
Yeah, and kind of like as an engineer on a project like that, the first time kind of you'll hit them is when you're breaking them, right? You'll make a change and like, I think this is fine, and then you send it to the commit queue and you break some layout tests, like what's happening to me today, and then you kind of have to drill into it, and the nice thing about layout tests is because each one is small, right? It's faster to figure out what you broke because it's just like hopefully only broke a small number of tests.
For sure. And it's a good example of why we have all these tests, right? Is to make sure things don't break. So, all right. That is pretty much all the questions I have written down. Is there anything else generally content layer, content public API-ish related that is interesting that maybe we didn't get a chance to cover?
Yeah, I mean, I can give like the most common kind of questions is people will be like, well, does this belong in content or not? So I can have a chance to point people towards like there's README files and content, /README that describes what's supposed to go in or not. And then there's also content public README that describes, the kind of guidelines we have for the API to make it consistent.
Mm-hmm. Yeah, I've definitely seen those kind of questions before. Like you updating one of the content public APIs, does this belong? While we're here, can you give us a quick breakdown heuristic of what things generally would belong in the content public API versus you put it up for review and the reviewer is like, no, this does not belong in content public?
Yeah, so sometimes, for example, for convenience, maybe the Chrome layer wants to call other parts of Chrome layer, but they don't have a direct connection, or maybe a Chrome layer wants to talk to a different component, and so they'll be like, okay, we'll add something to the content API, and then that way, Chrome can talk to this other part of Chrome or to this other component through content as a shortcut. We don't allow that, and the reason for that is, as anybody who's gone through the content public directory, it's already huge, and so kind of we kind of feel that if Chrome wants to talk to Chrome or to another layer, they should have their own API to kind of to each other directly instead of hopping through content, just because the content API is already very large, very complex, hard to understand, so we don't want to add things that are absolutely not necessary to it. And another kind of thing we try to do is to not add multiple ways of doing something. If we only add something to the content API when there's no other way of getting this data from inside content, or there's no other way of getting this data from the embedder to content. But if there's something similar that can do the same thing, we push back on that.
And also, test-only things, are those generally okay, or do we want to generally avoid those?
Well, yeah, test-only methods we try really hard, not just for the public API, but inside, because we don't want to bloat the binary. But we do have content public test, which is kind of gives you a lot more leeway to poke at things, to in your in browser tests, for example, or your unit tests. Another thing is, we also have um, kind of guidelines for how the API should be. Like we don't have really concrete classes; it's mostly abstract interfaces, and so there's a bunch of rules there, and they're all listed in content public README, kind of just so people know what the kind of guidelines we have for interfaces there.
On the Chrome binary point, how much is the size of the binary dependent on the size of the content public API? Is that a big part of the binary, or is it, small enough where, sure, we want to keep it from being unnecessarily large, but not too much of an issue?
Well, the size is not going to come as much from the content public API, but just from the entire content and all its dependencies. And those are in the tens of megabytes. So, sometimes, like, for example, if you're bundling the content layer, you're not going to be a small binary, right? You'll just start off in 30 megabyte range or 40 megabyte range once you put in everything together.
Right. And I guess that's something you have to be more conscious of if you're working in content versus another directory, even in Chrome, is that you have to be wary of your dependencies more so than anywhere else. Not only for Chrome, but also any other embedders who might want to use content.
Yep. Yeah, and so, for example, if someone's trying to add something in Chrome, like, we'll also ask, does this have to be in content, or can this be part of Chrome so that not every embedder has to pay that cost if they don't need it, right? And that's kind of, maybe we'll have an interface and the embedder can kind of plug the data in through that way, but still not have it in content. Another problem, of course, with having data inside content is that not all embedders update at the same speed. So if you're putting something in content, it can quickly go stale, the content, whatever the data is if you're not updating quickly.
That makes sense. So we mentioned a bit of what content is, a bit of the history of it. Can you tell us anything about what are upcoming changes that might happen in content? What is the future of the content directory, the layer, the API?
Well, it's kind of always changing. It's not static, driven by the needs of the product. And so you look at big changes happening today, like MP Arch to support various use cases that we didn't have or we never thought about initially. And that's kind of where like the web contents and side web contents, some of that comes in. There are kind of big changes like banning, for example, pointers and replacing them with raw pointer, so we can try to address some of the security problems we have with use after freeze. So that's kind of where, when you look at the content code or the Chrome code in general too, you might see it a little bit different than that kind of average C++ project that you see. You'll be like, oh, I'm getting errors if I try to have a raw pointer, and that's why.
Check out episode 1 for more on that. We'll link it below. All right. Anything else, random, content related or otherwise, you would like to share with us?
I think the only other thing I would add is, familiarize with yourself with the readmes in content readme and content public readme before making changes. That will make the kind of author and reviews time more efficient. And if you're working on content and below, you can build content shell instead of Chrome. That will be faster to build and debug, and hopefully make you more productive.
Good tips. Hopefully our viewers follow them. They would never try to, change a content public API without reading the readmes first, right? All right. Well, thank you so much, John, for sitting down and chatting with me about content. This was great, and hopefully people find it useful.
And thank you for hosting me, Sharon.
Did you start working on Chrome from the very start, or just, like, obviously, like pre-launch, right? Because I think based on your profile picture, it's a picture of that comic book that released when Chrome did, which I was lucky enough to get a copy of when I was an intern. Shout out, Peter. But that obviously suggests you were a major contributor before the public launch of Chrome. So were you working on Chrome from the very beginning?
I was not. It took about 6 months. I tried to join from the beginning, but I couldn't join right at the beginning. So kind of my sneaky way was I found another project under that same director who was running Chrome, and then once that project finished in 6 months, then I kind of jumped into Chrome.
Okay. And do you ever think about how crazy it is from, this thing that you worked on effectively from the start, right? I mean, before the public launch, to what it is now, where Chrome is kind of one of the foundational pieces of the internet at large, right? Like, anytime the internet gets run, period, probably something in Chrome is running, right? Like the net stack, if not, obviously, the browser, right? Like, do you ever think about that and how crazy that is and your place in that?
Yeah, I mean, it's kind of amazing, right, how far Chrome has come, and it's really humbling, right, to see it kind of be the number one browser, or the most widely used browser. Because when we were working on Chrome in the beginning, like we were just trying to guess what market share it would have, and people would be like, "Oh, it'd be 10%." We're like, "No way." Right? Like even like the people working on it, we didn't think that was going to be possible, right? So to kind of see users really enjoy using it, and kind of for us to keep demonstrating value by kind of sticking to our four principles, right? Like security and stability, simplicity, and speed, um, and seeing people not just adopt Chrome as a product, but Chromium as a platform is, yeah, it's beyond our wildest dreams. And it's kind of a responsibility that we have, right? Every time we make a change to Chrome, to all these users and developers who are using it.
Yeah, yeah,
Like
for sure.
you were asking earlier, like how does it feel to be from the start? You know, there's almost like a sense of like feeling super lucky, right? But also kind of this humbling kind of feeling where like, okay, we started in Chrome when it was really small, and our knowledge kind of built up kind of incrementally as it got more complicated. But it's always like, well, what if I was to jump in Chrome today? It seems like way too many. Like the code is so much complicated now compared to before. Like, kind of this kind of almost responsibility we have, kind of as being in Chrome for a long time, to share knowledge, to help people kind of pick it up, because we ourselves would have struggled, right, if we were jumping now.
Yes, as those people, we certainly did struggle.
Yeah.
But like people are pretty smart, I think, and they can figure it out. But that doesn't mean you can't make it easier for the people in the future figuring it out, or even people who like you just work on a different part. Like if I were to do anything in Blink, I'm just like, right, I
Same,
just don't know
same.
what
I've
you're
been
doing.
on Chrome
So
for a long time. I don't touch Blink.